Okay, so welcome back again to Embed System course. So we were discussing chapter number 1, that is 8051 programming in C, and I think we are about to finish this chapter in this lecture, that is lecture number 6. And in this lecture we are going to uh, discuss on how to access code ROM space in 8051 microcontroller from C programming language, and what is the data serialization and what is its application, and how to implement that for 8051 microcontroller in a C programming language. So these are the 2 points we are going to discuss in this lecture number 6. So first, let us discuss about accessing code ROM space in 8051 from C. So actually there are two types of memories, on-chip memories in case of 8051, that is RAM and ROM. And ROM we also call it as a code ROM or program ROM. Okay, now when we program 8051 from C programming language compiler, then how that RAM data space is utilized, that is shown here. Okay, so bank 0 register by default, these are used, okay, having addresses 00H to 07H, and these bank 0 registers are used for temporary storage. For example, whatever variables we will declare, okay, uh, from our C program, okay, that will get space in this bank 0, and if it exceeds, means more number of variables are there, then it can get space beyond this address, that is 0 to 7, that is from location number 08. Okay, so these individual variables will get space. Okay, if there are any array elements we have declared, for example, if we have declared any array type of variables in our C program, then these array elements from these arrays will get space from this RAM, okay, right after the variables space. Okay, so first variables will get space in RAM, and after that array elements will get space, that is the meaning. Okay, and if from your C program, if you are using stack, okay, or implicitly if your program uses stack, for example, by when you are calling a function, okay, from main function, in that case your compiler may use stack. In that case, stack memory from this RAM data space will be used, and it will get space right after all the array elements. Okay, in this way RAM data space will be utilized when we program 8051 microcontroller from a C programming language. Okay, now main point of our discussion is how to access code ROM space, that is program ROM or simply ROM. Okay, now normally this ROM, on chip ROM space in 8051 is normally used to store a code or program, isn't it? So in that case, your central processing unit, that is inside your 8051, by default accesses that program and executes it. Okay, but with this program or code, we can also utilize this code, remaining code or program ROM space to store some data permanently, okay, which is useful while executing your program or code. That means that data will be accessed from the program written in that program ROM or code ROM. Okay, that is the meaning. Then how to write that data with your program in code or program ROM of 8051, that is the main issue. Okay, so for that, in your program, if you write statement like this, that is code, then unsigned char my num square brackets is equal to, in double quotes, whatever string you can write, Okay, so what is the meaning of this statement? So this is obviously declaration statement. It is declaring my num as unsigned char type of array. Okay, means in this my num I can store at each location, or each element in this my num will be of type unsigned char, that is the number in between 0 to 255. Okay, and in that array I am storing these elements. First element will be 0, second will be 1, 2, 3, 4, 5, a, and last element will be d. So how many elements are there? There are 10 elements we are storing in this my num array. Okay, now if this before this unsigned char, this code, actually c should be small. Okay, so code keyword is there. If it is not there, then this my num array elements will get stored or get space in RAM. Okay, but what I want to do, I want to store this array or these array elements in code or program ROM space. Okay, that is the space that is remaining vacant after writing code or program. Okay, so if I write code here, then these elements will get space in program or code ROM. That is the meaning. Okay, so if here precede code, then this array or these array elements will get stored in program or code ROM. Okay, with your program. Okay, means when you generate hex file. Okay, so in that hex file there will be program as well as this data. Okay, so first program will get written in code or program ROM space, and then after that these data elements will get permanently written in code or program ROM space. Okay, that is the meaning. Okay, another example is given here. Code unsigned char, weekdays equal to 7, month is equal to 0x07. Okay, now meaning is this: here these weekdays and month I am declaring as unsigned char type of variable, and in weekdays I am storing number 7, and in month I am storing number 0x0c. Okay, so these two variables, since code keyword is preceding here, these two variables will get space in program or code ROM. That is the meaning. In this way I can only store, okay, while writing program or while writing hex file, I can also write data elements permanently in a program ROM space. Okay, so in this way I can write data permanently with our program in ROM space or program or code ROM space of 8051. But from program I cannot write such elements or data into program ROM space. Okay, next point is data serialization in 8051C. So what is a data serialization? As its name implies, serialization means that is of data, is a way of sending a byte of data one bit at a time through single pin of microcontroller. Okay, so for that I will use pen tab. Okay, so okay. Okay, so as I said, what is data serialization? On any pin of 8051, okay, for example any pin, okay, so I can output or I can input, okay, data serially. Okay, so for example data is 0 1 0 1 0 0 0 1, okay, 8 bits of data. So if I want to output it on this pin, first I will output 0, then 1, then 0, then 0, 0 1 0 1 0. Okay, so these 8 bits of data we are outputting serially on this pin. Okay, that is called as data serialization. Or if I'm accepting bits serially, okay, for example suppose on this pin I'm receiving data serially, then I can receive this data serially, okay, and I can internally I can store that data. That is, first after receiving 8 bits of data I can store it somewhere in RAM or that is in a variable or in a array, etc. Okay, so that is also called as data serialization. Okay, so data serialization means sending a byte of data one bit at a time through single pin of microcontroller, or receiving a byte of data one bit at a time through a single pin of microcontroller. Okay, so to implement this data serialization, there are two ways. First, that facility is already available, that is in the form of serial port of 8051. For example, um, there are two pins available. Okay, so TXD pin, okay, and RXD pin. Okay, so via this TXD and RXD pin, I can transmit data out. Okay, uh, by using this pin. Okay, and I can receive data serially on this RxD pin. Okay, and while transmission of these eight bits of data, that is 1 byte of data, the framing, that is start and stop bits, are automatically added, and while receiving, these start and stop bits are automatically separated, and only data byte will get received inside the 8051. For that, some SFRs are also used, and internally there is a hardware is there for to implement this transmission and reception of data serially. Okay, so in a serial port of 8051, we can transmit or receive data serially automatically. Okay, another option of data serialization is actually implementing serialization of data, okay, by using any IO pin of 8051. Okay, that is serializing data to transfer data one bit at a time and control the sequence of data and spaces in between them. Okay, so in case of serial port, so that sequencing, okay, so transfer of data and its timing and controlling the sequence of data, so everything will be done automatically in case of when you do serial transmission and reception by using serial port of 8051. But if you are using any IO port pin, okay, for serialization of data, okay, that is to transmit or receive data serially on any port pin, then you have to take care of all this timing, control the sequence of data and spaces, all these things. Okay, but it is possible. Okay, now this is important, that is data serialization is important because in many new generation devices, that is ICs, like LCD, ADC or ROM, okay, the serial versions are becoming popular since they take less space on PCB. Okay, means there are serial LCDs available, serial ADC is available, serial ROM is available. Means if you interface this LCD, ADC, ROM with microcontroller, whatever data transmission and reception takes place between these devices and microcontroller, that will be serial. Now what is advantage of that? Advantage is it requires less hardware, because you can compare parallel LCD with serial LCD. In case of parallel LCD, we will require 8 IO or data pins, okay, that should be connected between parallel LCD and microcontroller. But in case of serial LCD, only 2 pins are need to be interfaced between serial LCD and microcontroller. That will reduce hardware. Okay, hardware, on chip hardware of this LCD. This is very important advantage of using serial devices. Okay, now how to implement such a data serialization by using any IO pin of 8051 microcontroller. Okay, for that we will take example. Okay, so see here, write a C program to Okay, write a C program uh, to send out the value 44, okay, serially one bit at a time via port P1.0. Means what we are going to do. So suppose this is 8051, this is 8051, and this is pin number P1.0. On this pin we are going to out data 44H serially. 44 means 01000100, and MSB should go out first. Means first we should output, this is MSB 0. Okay, means 0 should be outputted first, then 1, then 0, then 0, then 0, then 1, then 0, then 0. In this way data should be outputted. Means first MSB and last bit will be LSB, and where it should be outputted on this port pin P1.0. Okay, so that is the task for this program is written. Now see, hash include reg51.h s bit p1b0. So we are declaring p1b0 as of type s bit, that is a single bit from bit addressable SFR, that is port 1. So what p1b0 is equal to p1 caret 0. So this will declare p1b0 as p1 caret 0, means p1b0 will now represent pin number 0 of port 1. Actually this statement is assigning address of pin 0 of port 1 to this variable p1b0, so that in remaining program, instead of using this p1 caret 0, I can use p1b0 symbol to represent pin number 0 of port 1. Okay, then I am declaring one more s bit type of variable, that is regAMSB. Okay, and it is equal to ACC caret 7. ACC means accumulator, and caret 7 means that is bit number 7, that is MSB of accumulator. So address of this bit will get assigned to this variable, that is regAMSB. Okay, means we are just representing bit number 7 of accumulator by using this symbol, that is regAMSB. Okay, now main program, void main void unsigned char con byte is equal to 0x44 semicolon. Okay, so this is declaration statement. I am declaring con byte as an unsigned char type of variable, and I am initializing it with value 0x44, which is the data byte to be transmitted serially on pin number 0 of port 1, that is on P1B0 pin. One more variable I am declaring, that is x of type unsigned char. Then ACC is equal to con byte. Okay, so what is ACC? ACC is accumulator. Okay, so I am assigning whatever byte is there in con byte to accumulator. Okay, so that means accumulator will have value 44. Okay, so I will write here. So now accumulator will have value 01000100. Okay, now after this statement, accumulator will have value 01000100. Then there is a for loop. For x is equal to 0, x is less than 8, x plus plus, means this for loop will be executed until value in x is less than 8, means starting from x is equal to 0 to 7. Okay, so this loop will be repeated. So these statements inside this for loop will be repeated how many times? 8 number of times, because value of x is varying from 0 to 7. Okay, so first time value in x will be 0. Okay, then this condition will be checked, and obviously it will return true. Then these statements in the for loop will be executed. So P1B0 means port number 1 pin number 0 or bit number 0 will get assigned with regAMSB. Now what is regAMSB? It is a bit number 7. See here, bit number 7 of accumulator. Okay, now what is bit number 7 of accumulator? So this is bit number 7, that is 0. So that I am assigning to port 1 pin number 0. Means ultimately first I am outputting this bit number 0, that is a bit number 7 in accumulator. Now what is in accumulator? In accumulator we have 44H, that is data byte to be transmitted serially on pin number 0 of port 1. Okay, so out of these 8 bits, first MSB I am putting on pin number 0 of port 1 by using this statement. Okay, means first I have outputted MSB of this data 44H, that is 0. Okay, and that is asked, we should output MSB first. Okay, now next ACC will be equal to ACC left shift by 1, means this data in accumulator, ACC means accumulator, that will be shifted left by 1 position and that will get again assigned to ACC. Means now if this gets shifted to left, okay, by 1 position, the new data will be 10001000. Okay, so this 1 will get shifted here, this 0 will get shifted here, and so on. Okay, so now this D6 bit will become D7 in accumulator. Okay, again X will get incremented by 1. Now value of X will be 1. Okay, again this expression returns true value, again these statements will be executed. Now see what happens. Now P1 B0 will be equal to REG A MSB. But what is REG A MSB? It is a bit number 7, that is MSB bit of accumulator. Now what is the MSB bit of accumulator now? It is 1. That is, we have shifted this data in accumulator by 1 position to left. So here 1 was there, it is now bit number D7 of accumulator. Okay, so that I am outputting to pin number 0 of port 1. Okay, now I have outputted 2 bits, first 0 then 1. Okay, again I am shifting left content of accumulator by 1 position. So now this bit will become or shifted to left, this will shifted to left. Now new data will be 0 0 0 0, sorry 1 0 0 0 0. Okay, again X will get incremented by 1, it will become 2. Again this condition returns true, so these statements will be executed. Again REG AMSB, that is bit number 7 of accumulator, will get outputted to pin number 0 of port 1, that is this bit 0 will get outputted. Means we are just shifting content of accumulator towards left by 1 position each time, and I am outputting whatever the bit number 7 of accumulator, okay, on pin number 0 of port 1. Okay, in this way all the 8 bits, all these 8 bits will get shifted to this bit number 7 and will get outputted on pin number 0 of port 1. In this way we are transmitting these 8 bits, okay, that is 44, serially on pin number 0 of port 1. Okay, with MSB first. Okay, that is MSB should go out first, that is been asked in the statement. In this way I can serially transmit given data byte, okay, on pin number 0 of port 1. So on any port pin I can do such serialization. Next program is write a C program to bring in a byte of data serially 1 bit at a time via same pin number 0 of port 1, and LSB should come in first. Okay, now see, so now we have to receive data serially. Byte of data we should receive serially 1 bit at a time, and LSB should come in first, and we should receive that data from pin number 0 of port 1. Okay, so first few statements are same like in previous program. Hash include reg51.h, s bit p1 b0 is equal to p1 caret 0, means I am representing pin number 0 of port 1 by using symbol p1 b0. Similarly I am representing bit number 7 of accumulator by using symbol ACC MSB. One more variable I am declaring, that is MEM bit of type bit. Okay, means in this MEM bit I can store 1 bit of information, any 0 or 1. Okay, Then void main void unsigned char x. I am declaring x as unsigned char type of variable which I am using in this for loop. So this is for loop for x is equal to 0, same for loop which will repeat for 8 number of times. For x is equal to 0, x is less than 8, x plus plus. Okay, so what statements are there in this loop? Mem bit is equal to p1 b0. Okay, so actually this statement, okay, this statement is reading pin number 0 of port 1. Okay, at this instant of time, okay, at this instant of time, whatever data is there on pin number 0 of port 1, that I am storing in variable mem bit that I have declared here. Okay, so mem bit will have whatever data on pin number 0 of port 1 at this instance of time. That could be 0 or 1, means I'm just reading what data serially available on pin number 0 of port 1. Then ACC is equal to ACC left shift 1. Okay, then I'm simply shifting accumulator by one position towards right. Okay, so irrespective of whatever data is there, suppose initially data in accumulator is suppose 0 0 0 0 0 0 0 0 0. Okay, so initially suppose all the bits of accumulator are 0. So due to this first time this accumulator content will get shifted towards right by one position, so there is no effect on this data in accumulator first time when this statement executes. Then ACC MSB. What is ACC MSB? ACC MSB is actually, that is bit number 7 of accumulator, that is this. Okay, so this ACC MSB is equal to mem bit. Okay, so suppose mem bit, when you read in mem bit data is 1. Okay, so that will get assigned to bit number 7 of accumulator, bit number 7 of accumulator. Okay, so that I am storing here. So after this statement, what will the content in accumulator? So this bit will become 1, this will become remain 0 0 0 0 0 0 0. Now next time x will get incremented by 1, again this condition will return true, again this statement will be repeated. So again pin number 0 of port 1 will get read whatever data there that will be available in mem bit. Now suppose data is 0, because we are actually receiving data serially on this p1.0. Suppose that data we are receiving is 1 0 0 1 0 1 1 0. Now first time this is available here, bit number D7 of accumulator. Now 0 is there. Okay, 0. So what will happen? See, so in mem bit right now 0 is there on pin number 0 of port 1, so that will get stored in mem bit, and accumulator is equal to accumulator right shift by 1. Okay, means whatever content in accumulator that will get right shifted by one position. Now so what will happen? So in accumulator this one bit will get shifted towards, okay, so this bit will get shifted in this way, all the bits will get shifted by one position towards right. So contents of accumulator will get like this. Okay, and after that ACC MSB equal to mem bit. Now what is in mem bit? That is next bit that is read, okay, by using this statement, and that is 0. It is 0. Okay, so that will get assigned to bit number D7, bit number D7 of accumulator. So this will become 0. Okay, now after that again x will get incremented by 1, it will become now 2. Again this condition returns true, again these statements will be executed. Now what is next data available on this pin? That is 0. So again 0 will get stored in mem bit. Okay, again accumulator will get shifted towards right. Okay, so it will become 0 0 1 0. Okay, 0 0 0 0. Again ACC MSB will get assigned whatever value in mem bit. Now value is still 0, so this D7 bit will get value modified 0. Okay, in this way all these 8 bits, which are being inputted serially to this pin number 0 of port 1 will get stored in the accumulator. Means after this loop repeated for 8 number of times, these 8 bits are available in accumulator like this. That is a 1 0 0 1 0 1 1 0. Okay, and see, we are shifting towards right because LSB here being inputted first. Okay, so this is LSB actually. Okay, so this is LSB. So actually this is wrong. So if this is LSB, then data will be 0 1 1 0 1 0 0 1. So this data will be available in the end in accumulator. Okay, so this is LSB and this is MSB. LSB is being inputted first because that is given in the statement. Okay, so depending on whether LSB is being inputted first or MSB is being inputted first, here you have to modify this statement. Okay, how? Let us see. Now there is one more program to transmit data serially. Okay, and okay, we actually missed one program. Okay, first we will discuss this. Okay, so this is a program to receive data byte serially, one bit at a time, but the MSB should come first. So program is same like previous one. Okay, so this program and this program is same, but only difference is in previous program LSB should come in first. Okay, so whatever first bit that will get received on port 1 pin number 0, that will be LSB in this program, and in this program that we are assuming that bit will be MSB. Whatever bit first bit we will receive on pin number 0 of port 1, that is MSB. Okay, now see the difference between this program and previous program. So here we have declared, okay, here ACC MSB, okay, we are declaring as pin number 7 of accumulator. Instead of that, REGA LSB we are declaring as bit number 0 of accumulator, because right now what is happening here? Here MSB is being inputted first. Okay, so for that purpose, bit number 0 of accumulator we are representing by REGA LSB. And see here we are shifting accumulator, okay, towards left by one position instead of towards right in previous program. Okay, now see here we will discuss whole program. Include reg51.h, s bit p1 b0 is equal to p1 caret 0, means I am representing pin number 0 of port 1 by using symbol p1 b0. Next, REGA LSB, I am declaring REGA LSB of s bit type of a variable which is representing bit number 0 of accumulator. Bit mem bit, I am declaring mem bit is that is variable of type bit in which I can store information of one bit, that is either 0 or 1. Then main function, void main void unsigned char x. Okay, I am declaring x as unsigned char type of variable which is used in this for loop. For x is equal to 0, x is less than 8, x plus plus, means whatever statements in this loop, these statements will be repeated 8 number of times because we are going to receive 8 bits, okay, on pin number 0 of port 1, p1 b0. Okay, so first I am reading what is data on pin number 0 of port 1, okay, into mem bit. Okay, so after execution of this statement in a mem bit, what we have, whatever data 0 or 1 available on pin number 1, pin number 0 of port 1. Then suppose accumulator initially contains suppose 0 0 0 0 0 0 0 0 0 0. Okay, suppose accumulator contains 0 0 0 0 0 0 initially. then we are shifting accumulator towards left by one position, so there will be no effect on this data initially. When first time this statement executes, there is no effect. Then reg a lsb is equal to mem bit. So whatever data is there mem bit, which we are assuming msb of data byte being received on pin number 0 of port 1, so that msb bit, okay, I am that we have in mem bit, that I am assigning to reg alsb, which is actually bit number 0 of accumulator. Okay, so okay, so first time when this statement executes, there is no effect on data in accumulator, or we just ignore whatever change happens. Next, due to this next statement, whatever data in mem bit, that is data bit received via this pin number 0 port 1, okay, that will be assigned to reg alsb, which is actually bit number 0 of accumulator, means this okay, so this will be modified according to whatever data is there in mem bit. Suppose data being received on p1 0, that is pin number 0 port 1 is 101111010. Okay, so this is msb, so that will get received first in mem bit, and that will get assigned to bit number 0 of accumulator, means this will get modified to 1. Remaining bits will be 0 0 0 0 0 0. Okay, so when first time this loop executes, what will happen? msb will get received at this bit number 0 of accumulator. Next, x will get incremented by 1. Again this loop will be repeated. Now mem bit is equal to p1 b0. Again pin number 0 of port 1 will get read, and whatever data now available, what is that data now will be? It will be 0. That will get received in mem bit, and then accumulator will get shifted towards left by one position. Okay, so now data will be here 0 0 0 0 0 0 1 0, because this will get shifted towards left, this will get shifted towards left by one position. Okay, and this data in mem bit will get assigned to bit number 0 of accumulator, means here. Okay, so in this way all these bits will get received serially. Okay, msb, assuming that msb is inputted first. Okay, and after execution of this loop for 8 number of times, okay, all the data will be available in accumulator, that is 1011 1010. This data, okay, being inputted on pin number 0 of port 1, okay, that will be available in accumulator. Okay, and that finally we are outputting to port 1, port 2. Whatever data byte that is received serially, that will get outputted to port 2. Okay, assuming that msb is being inputted first. Okay, so in this way, depending on whether msb is being inputted first or lsb is being inputted first, you can modify your program. In this way you can receive data serially. Okay, now here in this program we send out data serially, that is 44h, we send it out serially, assuming that msb should go out first. Okay, in this program same data byte 44 we are outputting serially on pin number 0 port 1, but assuming that this lsb bit is being inputted first. Accordingly there will be modification. See the difference between this program and previous one. This program, here I am declaring reg amsb as bit number 7 of accumulator. Instead, since lsb is being transmitted first, here bit number 0 of accumulator is being declared as reg alsb. Okay, and instead of shifting data towards left in the accumulator after receiving each bit, after transmitting each bit, here in this program where lsb is being inputted first, accumulator is being shifted towards right by one position each time. Okay, after receiving each bit, because lsb is being inputted first. Okay, so see the difference between these two programs. Transmits data serially, and these two programs receives data serially. Okay, for in first program LSB is being inputted first, and in second program MSB is being inputted first. Okay, so in this way we can implement data serialization by writing C program for 8051 microcontroller. Okay, so you check these programs. If any doubts, we can discuss in our live session. Okay, I think I will stop here.